Limit of radical functions and indeterminate forms. Example 1.15, using the conjugate to find the limit of indeterminate forms. So let us get the limit of this function as x approaches 0. So if we were to apply our limit theorems, this is equal to so this is an indeterminate form. So we cannot say that this is equal to 0, this is not equal to 1, this is not equal to infinity. So we must do something. So the titling of this slide is telling you what we can do. We can multiply it by its conjugate. So let us see what will happen if we were to multiply this function by the conjugate of the numerator. So x divided by x is 1. And so we are left here with 1 over square root of x plus 9 plus 3. The limit of our function is equal to the limit of 1 over the square root of x plus 9 plus 3 as x approaches 0. And what is this equal to? Square root of 0 plus 9 or square root of 9. And that is equal to 3. So what we have here is 1 over 3 plus 3. And so this is equal to 1 over 6. Let us get the limit of the square root of x minus 3 divided by x minus 9 as x approaches 9. This is another indeterminate form. So what I will do is, I will use the conjugate and let us see what will happen when we multiply this function by its conjugate. So this factor here is just equal to 1. And so multiplying that to our function does not change our function. We are working on the same function. X minus 9 divided by x minus 9 is equal to 1. And so we are left with 1 over square root of x plus 3. So the limit of our function is equal to the limit of 1 over square root of x plus 3 as x approaches 9. And so this is equal to 1 over square root of 9 plus 3. And this is equal to 1 over 3 plus 3. This is equal to 1 over 6. Let us get the limit of the square root of 5 times x minus 5 divided by x squared minus 25. So this is an indeterminate form. You know what? When you're working on this, if this were an assignment and if the instruction to you is show your solution, you must show that this is an indeterminate form before you can go on using the conjugate. So this is an indeterminate form. This is the conjugate of our numerator. And multiplying this factor to our function does not change our function. We are working on the same function. Now what I'm going to do is I'm going to produce a factoring for x squared minus 25. This one is easy to see the factoring. This is the difference between two squares and we know it's factoring. Okay, I'm going to factor out 5 from the numerator. So it's going to be 5 times x minus 5 and then divided by x minus 5 times x plus 5 and then times the square root of 5 times x plus 5. Okay, so look at this. X minus 5 divided by x minus 5 is equal to 1. And so what we have here now is 5 divided by x plus 5 times the square root of 5x plus 5. So what is the limit of this function as x approaches 5? So the limit of this function, okay, which is equivalent to our original function, which is equivalent to that, the limit of 5 divided by x plus 5 times the square root of 5x plus 5 as x approaches 5. What is this equal to? So 5 plus 5 is 10 times, this one is 5 times 5, that's 5 squared. And the square root of 25 is 5. And so this is going to be equal to, okay, 5 divided by 10 is 1/2. And so what we have here is 1 over 2 times 10, which is 20. How about this one? So this one is equal to 0. Okay, so this one is not an indeterminate form. It is just equal to 0.